Hi, I'm James Corbett. I'm going to be doing a demo of my AI chatbot. It's based on F1. So I'm just going to start off with the AML patterns and show some examples of them. So um, let's just start off by doing that. So go hello. I'd say good. So up, I can say F1. So as you have great taste, I hate F1. Opinion is invalid. Yeah, you can also do some others. Scroll down here. Formula One is boring. Let's just do that. Understanding and knowing on, you'll appreciate a lot more. Yeah, let's just do a couple more. Looking forward to next season. Just to show this all working. Yeah, so I think George Russell will be world champion. Right, just do one more. So you can just say someone is a bad driver. So Lando is a bad driver. That's the AML. Yeah, I've got expanded conversational patterns here. It's got over 10. And then you've got input logic. I'll cover that later. All right, so now moving on, I'm going to cover the KB questions. The question bank question answers. So if I type in who's your favorite driver, I'm going to respond with my favorite driver is George Russell. Let's just try a couple of these. Who was the 2022 world champion? Verstappen. How many points did they get as first get? Yeah, first received 25 points. So let's see. When was F1 founded? Let's try that. Yeah, see, it's all working fine. Let's just try one more. Who was the best pit crew? Okay, Aaron has the best pit crew. They hold the fastest stop. Right. So next I'm going to cover the KB side of thing, the knowledge base. So I'm just going to ask it a couple of patterns based on what I need to do for that. So this is the what do you know, and check that, and I know that. So we could do check that Charles Leclerc is race winner. So check that Charles Leclerc is race winner. That's correct. You also check that he's world champion. He's not a world champion, so this is going to be false. Check that Charles Leclerc is world champion. Yeah, this is incorrect. Yeah, this is just down here to make sure that you're doing it correctly, because if you put in the wrong pattern, they might not be able to find the name because it's the same as if it's spelled wrong. You can do it if it's spaced out though. You could do the same thing and it would just capitalize it for you. So I can remove the capitalization on both of these. It still recognizes it. If it wouldn't recognize it, it wouldn't be incorrect. It just wouldn't be found. Okay, so now we could do I know that Charles Leclerc is one champion. We should change it. So let's just do that. I know that Charles Leclerc is world champion. Now, I think for this one, I might need to do it in a different pattern. Charles. This one I need to do Charles Leclerc. Spelled how it is in the database. So Charles Leclerc is world champion. So this is incorrect. Oh yeah, I need to. I know that Charles Leclerc. Okay, I will remember that Charles Leclerc is world champion. So now if I do that if I do the same command as before, it will come up as correct because I've saved it in the knowledge base. Yeah, this is correct. So that's, and then just the last one for the basic functionality of this, do the pattern down here. This is what we were doing. So the what do you know one. What do you know? Yeah, what do you know? Okay, let's just see that working. So just put out everything that knowledge base knows. So all of the rules that it's got. And now you're going to do the rating system. So for the extra functionality, I've done a fuzzy logic rating system, which you can see here. So I've got max driver season points, lifetime race wins, champ titles, and the rating overall, and then that gets converted into good, very good, legendary, and then bad if they're bad. So you can do rate Lando Norris. They are good. Let's try and rate someone else. So you can do any of the drivers here. I've got all the drivers listed. So you can try Nick de Vries instead. They're quite a new driver, so they're probably not good. Yeah, they are bad because it's done on their racing history. Got all the data down here. Let's just do one more or a couple more. So rate Verstappen, they're very good. And then Michael Schumacher, he's got a really, really good racing history, so he's legendary. Yeah, legendary status because he's won world championships and has lots of race wins and the stuff that makes it rate highly. So next, I'm going to do the image analysis based on the text analysis based on the image. So if we go here again, pattern for this is down here. It's in the input. So it is show me text from, and then the image with the extension in the language. So if we go to our images folder, I could try road sign here. It's a good example because it shows, or I could try either other ones. So road sign, so let's see, roadsign.jpg. So what was it again? Show me text from. Show me text from road sign. JPEG in English. Let's do English first. English. So this is the output. And if you go to the plots, you can see that this is the output that it gives you. So yeah, so it's accurately taken all the text and put it out. So now let's try that in a different language. Let's just show that's working. Translation. Let's say German. Do it in German. Yeah, it just puts out in German. So that's so this is task D, this translation one. And for the extra functionality, what I did is I've got the translation and the speech. So the speech is done in Azure as well. It's here, so it's the speech output, speech synthesizer. And the translation is also done Microsoft Azure. So yeah, you request and then receive in the JSON, and then print out the result from the translation. And I'm also passing in the language. So I'm passing in a language, it automatically detects the language that it's coming in because I haven't specified it, and the language gets converted to its basic form down here as well. I'll cover this more and explain the code more in a second, but I'll just show where it was now. Yeah, it's down here. So langcode.find. This takes the input language. So I put English then. So short lang just shortens it down to EN. So it can be read by the Azure API, language translation API. Okay, so I'm just going to do the last functionality, then I'm going to cover more of the code. So show me in language say word, so in French say. Okay. Try a bit more if you want to do so. In German say. Yeah, so there you go, that's what it gets translated. So all it does is basically takes your text input, pass it to translation, and then if it's in English, it won't, or if it's in English, it won't translate it, it'll just put it straight out, and it'll just put it straight out to the speech. And if it's not, it'll just speak it. So, or if it's in a different language, it will just translate it and speak it. So, yeah, that's that for that functionality. And then I'm going to cover some more of the code to show the execution, how things work. So I've got class up here, AI agent, which stores some of the information I need. Yeah, and the dependencies here, this is what you need to make sure everything works, because I'm using some libraries and packages that might be needed. Got TF IDF vectorization. Yeah, this was for the input to make sure it accepts a wider range of inputs, and then the lemmatization. Is that working here? Fuzzy logic, yeah, that was what I've just shown. The driver ranking system. So yeah, you use triangular functions and the Mandani inference, and then got speech entry. I haven't tested this out, so I should do that now. So that was the extra functionality from task 1. So I need to do, can I use speech? Do a quick demo of using the speech in my app. So if I do, can I use speech? So can use speech. Now using speech entry. So hello. Hello.
Hello. How
Good.
are you?
Good, thanks. Good, thanks. Good.
That is great. What can I help you with?
Lando Norris is a bad driver.
I'm sure that's not true.
Okay, well, I think I got confused with what I said there, but yeah, that's the text to speech feature. So if I could say, can I use text? Can I use text? There you go. So if you say that, it goes to text entry. There's a lag between saying it and happening, but yeah, so that's that feature. Right. So as I was saying before, so you go through the initial questions in the AML file, and then what happens is you reach pattern that then makes it go to the other one. So what it does is after it goes through this AML file, it goes down here and in the 99 section. So it hasn't found anything here. Yeah, there's no pattern found. So then what it does is it goes down here, and then if answer index equals 0, it gets the CSV answers. So .get CSV answers from the agent is called. Get CSV answers. So this just returns the index of the answer you've given. So it'll just output whatever pattern matches. So yeah, it'll just give the correct response to the user. So I think that covers everything. Thanks for listening to my demo. Actually, I'm just going to cover this section quickly first. So you got when doing the text from image, it calls Azure API, the cognitive services. So you pass it your key and endpoint, and then it goes through. You can get the results from it. You can submit the image, and then you get the results. Then you loop through them. You can do whatever you want to them, like drawing bounding box here. And then I put them into a list, and then for this case, I pass it to the translation with the language that I want to translate it to, and then I get the output as I did before. So that's everything. Thanks for listening to my demo.